Hello everyone. So today we're going to start the chapter 1 class 10 mathematics chapter 1, that is real number. So in this chapter we have 4 exercises based on various things. So before going to the chapter we have to clarify some of the basic terminology that we have already got in our previous classes about whole number, rational number, irrational number. Then only you can understand what is a real number exactly is. So actually real number is the godfather of every number, and how it is, let me explain it. So before that, let me clarify some of the basic terms that you have already learned in your lower classes. You might have forgotten that one. So first thing, let me clear it about. So you know what is a natural number? It is a very natural number. The sequence of those number which start from 1 means the number series which start from 1, you can consider it as a natural numbers. Means the number which series which start from 1, 2, 3, 4 and infinity. There is no any boundation, there is no limit of the extension. It will go as much a number you can think in the positive direction. So this is called the natural number. So I'm not making you write the definition, it will not come in your exam. Okay, just to clarify, just to rewind the earlier concept what you have already learned about. So now number 2, the concept is your whole number. Is whole number. It's just quite similar to this, but in this case, in this whole number, what happened? The sequence number which start from 0 means 0 to the positive extent to whatever number you can think of. So there is it start from 0, 1, 2, 3, 4, infinity. So this is the thing. That means the natural number. What is that? The number which sequence which start from 1, while the whole number is the sequence which start from 0. So let me ask you a question. If I say you every natural number is a whole number, let me repeat it. Is every natural number is a whole number? Definitely yes. Because why? Because natural numbers start from 1, while whole numbers start from 0. That means 1, 2, 3, 4 is already included. That means already natural numbers included. So we can say that natural number are the whole number. But if I revise the question, that is every whole number is natural number? Exactly not. Why so? Because whole number what is there? It starts from 0, and we know that in natural number 0 doesn't come. So we cannot consider that every whole number is not a natural number. So now the next term that we got is your integer. It's integers. So very nice term. Means what is integer actually? Means all the positive and the negative numbers in a number line. I'm not saying about any fractional or decimal points. Numbers only. So if I say suppose this is a number line. This is number line, and this the midpoint is 0. If you go to right extent, so you will get positive quantity 1, 2, 3, 4, that is a positive infinity. If I go to left hand side, extreme left hand side, what you will getting? You will be getting -1, -2, -3, -4 and so on. It is negative infinity. That means all these number, whether it is a positive or negative, all these group of numbers we can consider it as a integer numbers. Means all the negative and positive numbers are considered as a integers numbers. I hope it is clear. Now there is one more question arise. If I ask a question now here, that is every natural number is an integer? Obviously, definitely, because all the positive quantity starting from 1, 2, 3, 4, it already comes in integer. So I can say that all the natural numbers are integer. If I say is all whole number is an integer, obviously it starts from 0, and 0, 1, 2, 3, 4 infinity is already included in this segment. So we can say that every natural or the whole numbers are the integer number. If I rewind the question now, if I say now, is every integer is a whole number? Absolutely not. Is every integer is a natural number? Cannot be. Not possible. Why? Because integer include the negative integer, and which is not possible in case of a natural number. So I hope the concept is clear, everyone. So now next points comes here. I will just simply for sake of knowledge and understanding, let me clear this point. There is one more number that is called fractional number. You are very familiar with this fractional number. Fractional number. What is this? Fractional number are what? which can be written in P by Q form. 2 by 3, 4 by 5, some are proper number, some are improper number, 6 by 4. So these are what? Which are written in, which has denominator and numerator are called as fractional number. You know all these things. Now our main topic start, that is the rational number. It is point to be concerned and try to understand what I am saying, that rational, not natural, it is a rational number. So fifth, I am saying that rational number. Rational number. How shall I define it? Means, as a definition, as a bookish definition, it says that the number which can be expressed in the form of P by Q, where Q is not equal to 0. It is the bookish definition. What does the bookish definition says? The number which can be expressed in the form of P by Q, where Q is not equal to 0. Where Q is not equal to 0 is called a rational. For the sake of understanding and more moral understanding, let me give an example. Consider, I'm searching for a geometry box. Where it is geometry box? Explain the term with the example diagram of a geometry box. As you know, let me consider this pens, refill, this compass. These all are, suppose, a natural number. This is natural number. So the natural number I keep inside a geometry box, and this geometry box is your whole number. So I can say that all the materials or the objects are included in the whole number. So these pencil, rubber, eraser, whatever we will say, these are the natural number, and this whole geometry box is your whole number. That means all the natural numbers are included in whole number. Now consider one more thing. This pocket, so this pocket, whatever pocket, what I am considering it. So my pocket, so integer, let me put in this pocket, so integer. So as you can see, the integer includes all the whole number, and the whole number include all the natural number. That means the integer comprises of all the whole number, natural number, whatever. I hope it is clear. And consider my blazer. My blazer is a rational number. It's a father of all, the father of all. So this rational number means, so whatever is in my blazer, it is a rational number. That means my blazer include the pocket. This pocket is integer, so integer is also included in the blazer. That means in the rational number. Even the geometry box was the whole number also included in my blazer. And even the geometry box consists of also instrument like pencil, rubber. Those all are also included in my blazer. That means the rational number includes all these for this term. Okay, the rational number includes natural number, whole number, integer, fraction number. Everything is included in the rational number. I hope the definition is quite clear and the way I explained is clear. So thing is that now there is one more term left, that is irrational number. So as an example, let us consider irrational number is my pant. All the pockets that have in my pant, my pant is a irrational number, and the pockets considered as irrational number. So there is no any link between my blazer and my pocket, my pant pockets. That's a real difference. So let me explain it so that you can understand very well. So let us come to this point. Is a rational number means the number which can be expressed in the form of P by Q, where Q is not equal to 0. Definitely. So everything is, these all are, a rational number includes all these, father of all. This is the father of all. Means everything, whole number, natural number, integer, fraction number, all are included under rational number. So one more doubt you might be having. So it is said that every number which can be expressed in the form of P by Q. Are sir, how can be natural number be a rational number? Rational number include 1, 2, 3, 4. How can we express 2 into P by Q? Obviously we can convert it, or we can write in the form of, obviously can't we write 2 as a 2 by 1? Because the denominator is included in every number. 1 is the universal denominator of every number. So we can definitely write that 2 by 1 in the form of P by Q. That is why we can say that all these natural, integer, whatever are all your rational number. So I hope it is clear. Now let us come to the next point. Means every number, means all the numbers, natural number, whole number, integer, fraction, all are the rational number. I hope that point is clear. Now let us come to one more term, that is irrational number. Definition is quite simple for the rational, quite relevant to the rational number. As it is given that can be expressed, it will be cannot be expressed. That's simple definition. So let me write a term for you. Q is not equal to 0. Simple term, the simple definition, I will just say, the number which cannot be expressed in the form of P by Q is called irrational number. So can you think of a number which is an irrational, which cannot be expressed in P by Q form? So very well, you are very quite familiar with this term, I hope. So if I take any imperfect square such as root 2 is an imperfect square. We do not have the actual value, okay, of root 2. So root 2, if you go on finding the decimal, it will be getting 1.41 something, never ending process. That is why we consider that root 2 is not a rational number. So if it is not rational number, why it is not rational number? Because we cannot express root 2 in the form of P by Q. That is why it doesn't fall under the category of rational number. So what to do? The scientists thought to let them categorize in different category, and that category is your irrational number. Means here the number cannot be expressed in the P by Q form. There is lots of examples are there. If we consider root 3, this is also an example of a irrational number. Even root 5, every imperfect square is a perfect example of a irrational number. Even the value of pi is also irrational number. Remember, it's come many a time in board, CBSE board. So clear it up, my dear. So now the last point comes, that is real number. As already in the beginning of the session, I just say you that what is a real number. It is the godfather of every number. That means consider my body. My body is the real number, and this blazer was a rational number. My pant was irrational number. So my body includes all these things. My body includes blazer also, even my pant also. That means all the rational number and irrational number together comprises to make a real number. That means it's the godfather of every number. Whatever number you can think in your brain, those are all categorized under the category of real number, and that's what we are going to deal in this chapter. I hope those terms are very clear to you. If I ask you, you can reply it, and whatever I have given, just try to recall in your brain, otherwise you will be confused. So this is what. So let me remind one more thing, as if I make a very long video of the whole chapter to take a language. So what I am doing is that I will make a segmented video on this basis. Suppose based on the exercises, if the exercise is very large, I will be breaking into 2-3 videos. So as this exercise consists of four exercises, so I will be trying to make 4 different videos based on it. So here till yet I have given just a introductory portion of the chapter, and now let me write. So this, what is real number? It is the godfather of both rational and irrational number. So here we can say that the real number comprises of 2 numbers, that is what, a rational number and irrational number. And what is the rational number? We can explain the form of P by Q, and this number includes all the other numbers such as natural number, whole number, integer number, fractional number, and these include which cannot express in P by Q form. Example, root 2, root 3, root 5, this is the number. I hope it's clear. Now the real number, actually we do not need the definition. Means the number, what we can write, real number, we can say the godfather of every number. Don't write it, just to make you understand. The godfather of every number. except imaginary line or iota wala line, numbers which you will be getting in high secondary, not now in class 10. So the godfather of every number, or we can also say that the number comprises of rational or irrational number is called real number. For the sake of understanding, I just make you given just a small definition, so that if somebody asks you, you can easily reply to them. So alright, so this chapter real number I like to divide into 4 topics. And what are these topics? I'll just let me write for you. Topic best on this chapter are as follows here. The first topic that I like to carry on, that is your Euclid division lemma. And on this topic, your exercise 1.1 is totally based on. If you understand really this topic, then you can easily do exercise 1.1 easily. Now the next topic will be the fundamental theorem of arithmetic. And on this topic, that whole exercise 1.2 is based. And third topic is your proof of irrational number. So numbers such as root 2, root 3, root 5, root 7. So in that in this topic we will learn to prove those irrational numbers are really they're irrational or irrational. And based on this topic, we have to deal the exercise 1.3. The 1.3 exercise is totally based on this topic. And the last topic will be your type of decimals. So according to the decimatory points, so there is mainly basically two types of decimal, that is 2 to 3 type of decimals. That is what? First is your terminating decimal. Terminating decimal. And we are very familiar with this decimal. Such as the number would get finished, like if we divide 2.4 divided by 2, that is 1.2. That means 1.2, 6.42 means which has a ending. Are called, the name itself says terminating. Terminates. The decimal terminates. Khatam ho jata hai wo. The next is your non-terminating, repeating, or it also says recurring. The next decimal is your non-terminating, repeating. It doesn't finish but it goes on repeated. means जो खत्म नहीं होता लेकिन repeat होते रहते हैं. Example 1.2222. So you can see never ending, but what happens is that the decimal points goes on repetition. If I say 6 point, like example 42, the number goes on repeating on a frequent interval of time. So what happens is that this is another form of decimal. So the third form of decimal is your non-terminating, खत्म भी नहीं होता है, non-terminating, non-repeating. It is neither stopping, neither is terminating nor it is repeated. So this is also example. If I consider so 1.23167812 the value of pi or whatever, like root 2. So what will 1.416 continue. There is no ending in the decimal digit. Neither the numbers are repeated. So these are the 3 category of decimal. Okay. So decimal, terminating decimal, non-terminating repeating, and non-terminating non-repeating. So let me recall or remind a very important point from this topic. Remember these two, out of these 3 decimal point, these 2 decimals are considered as a rational number. They are considered in the category of rational number. The scientist has given different platform for this. And this singly, which is non-terminating, non-recurring, and it is considered as a irrational number. Irrational number. This is what the topic says. Okay, by the way, I'm not going to cover all the points in a single video. It will be very lengthy and boredom. So what I'm thinking is that in this, I will try to make a specific and individual video. So in this video, I will only carry out with this topic, that is Euclid division lemma. I like to carry out this point. What does actually it mean? It's a very basic funda. It's a very normal thing, and you had dealt with it many a time, but you are not familiar with this term. But let me make you familiar. So let me write a definition for this. So Let me read out the definition so that for more clearance and confirmation. Any positive integer a and b, there exists unique integer q and r satisfying a equal to bq plus r, where r is less than b or more than or equal to 0. So you might be thinking, "Arey, what is this, man? Kabhi dekha nahi." So first of all, let me start with a very basic example. I think you are very familiar with division, no? So if I say you divide 7 divided by 2, how will you divide this? So how will you divide? You will take it inside 7 divided 2 3s are the closest number you will be taking. 2 3s are 6. Remainder 1. What actually we say? What is 7? The 7 is dividend. Dividend. And 2 is what? 2 is your divisor. 2 is your divisor. And what is 3? 3 is your quotient. While what is 1? 1 is your remainder. So we know from our basic, from the earlier classes, from the small classes, we know, if can I write that 7 is equal to 2 into 3 plus 1, that means we know that dividend is equal to divisor into quotient plus remainder. It is not a new thing. We already had learned this one in our basic classes and the small classes. Same thing, nothing to bother. Same thing is here also. Just we replace division, divisor, quotient with some alphabetical order or with some variable. So here this dividend is written as A, and this divisor is written as B, and this quotient is written as C, and the remainder is denoted by R. That means if I write the dividend is what? A. Divisor is what? B. Quotient is what? Q. Plus what is remainder? Remainder is your R. And here the formula comes. A equal to BQ plus R. And we already know that remainder cannot be more than the divisor. Also not less than 0. It can be equal to 0. For example, if it is a complete factor, suppose if I divide 10 divided by 2, 2 5s are 10. Here the remainder is 0. That means the remainder should be equal to 0, या फिर more than 0, या फिर it should be less than 2. It cannot be more than it cannot be more than the divisor. We know this thing. If I say now, suppose 7 divided by 2. Suppose if I say, suppose 9. Suppose divide 2 by 9. 2 4s are 8. We know. So remainder is 1. If I do some wrong calculation, in what case the remainder can be more? Suppose if I write here 2 3s are 6. The remainder is 3. So here we can see the remainder is more than the divisor. अरे divide ही गलती है तुम्हारा. तो याद रखना, just always keep in your mind that the remainder cannot be more than the divisor. That means the value of R cannot be more than B. It should be less than B, means divisor, or more than or equal to 0. This is the basic funda that I am going to clear here. So I hope it is clear, and let me explain this one. Every positive integer A and B, there exists unique integer Q and R. Obviously, definitely. For every divisor and dividend and divisor, there exists different quotient and remainder. Obviously, if I say you divide 7 by 2. If I say you 7 divided by 2, so what will be the quotient and remainder? Obviously, look here, 7 divided by 2, 2 3 is 6, 1. Here the remainder is R1 and the quotient is 3. Now if I say you divide 8, A divided by 4. Now if you see A divided by 4, 4 2 is 8, 0. That means the 2 is what? 2 is your quotient. That means what? We can write it Q, and 0 is your remainder. That means for every unique or for every different A and B, means a dividend and divisor, there exists a unique, means there will be some different varying a variety of questions as well as remainder. I hope the point is clear to everybody. Still, if you are confused, then the WhatsApp number is even given. You can contact directly to me. So my dear, now let us begin with exercise 1.1. And here goes your questions. Use Euclid division algorithm to find the HCF of 135 and 225. So there is lots of traditional method we have learned in our basic classes, but we'll not do that way. We'll not do it separately. Suppose 135, here is 225, factorizing it and finding the common between them. It is not the way that we will dealing in the class 10. We have to go stepwise. We have to use the Euclid's Baba's law or Euclid's Baba's theorem to continue with this steps. So here, which is the larger number now? 225 or 1? Obviously this number. So this will be acting like a dividend here. So here, what I can write? Here 225 is more than 125. So what we will be using? We will be using the Euclid Baba's lemma. So using Euclid division lemma, what we can see, let me divide and see, that is 225 divided by 135. If I met with 2, it will be more larger than the dividend. So 1 ja 35, 135 into 1 ja, so 550, 12 is 5, here comes your 9, so 90. So as you can see, we'll go step and watch. Directly we won't do it, but later on in the coming exercises we will do it directly. But here we have to deal with stepwise to make to explain it, elaborate everything here. So you can see that 225 is equal to 135 into 1 plus 90. So our main motto or intention is to make the remainder 0. So here we have not got the remainder 0. So we have to continue the step. So you can see now again applying Euclid division lemma in this Euclid division lemma. So if you apply the Euclid division lemma, here this 135 is acting like a dividend and this will be as a divisor. So the larger number will be in the box. 135, 90 ja 91 ja 90. If you take 2, it will be more than the dividend. So what you will get? 45. Still we have not got the remainder 0. We have to carry out the step further more times to get the remainder 0. So here what we found, that 135 is equal to 90 into 1 plus 45. Again we have to carry out the step, carry the step furthermore. So again applying again the Euclid division lemma, so what will be here? Divisor 45 dividing to 90, and we know that 45 is a perfect factor of 90. 45 2 ja 90. So ultimately rahat, we got the remainder 0. So our answer is also. This is the reason, this is the number which is responsible for making it 0. So definitely the HCF of 135 and 25 will be your 45. Therefore I can write, therefore the HCF of 135 and 225 is your 45. I hope it's definitely clear. Still you have not understood, please rewind the video. So this is the next question here. So use Euclid division algorithm to find the HCF of 196 and 38220, means 30,220. So it seems like quite a big number. You might be very worried about looking at this big number. So what we can see, this number is larger than this. So it is definitely, this number will be acting like a dividend here. So here what we can write, here 38,220 is greater than 196. So same thing, same step, you will use the using Euclid division lemma here. So while using the Euclid division lemma, so what we can see, that 38,226, 196. As you can see from my ideology, I found that this number is a perfect number. Perfect means the factor of this number. That's already I have done many a time. So so if you multiply 195, you can see you will get 30,220. That means This number is only enough. We have not to carry the further step here. So this number is the HCF. The answer ends here only. Finish this much only. So what we can write here? Therefore, is what we can write that 38,220 is equal to 196 into 195 plus 0. That means the HCF is 196. Therefore, the HCF of 196 and 38,220 is your 196. Finish. Now one more question. So here goes the third part of these questions. Same questions, how to find the HCF by using the Euclid division algorithm. Here you can see 867 and 225. You have to find the HCF of these two numbers. So as you can see, this number is pretty larger than this number. So we can say that here, what is larger? Here 867 is greater than 255. So it will divide this. So what will use to the same line will be repeating in using what or applying whatever, applying or using whatever you wish. Applying Euclid division lemma, what you can write here, 867 divided by 255. As you can see, 255. If you write 2, 510. 3 ja, 3 5 ja, 15, 1, 15, 3, 15, 16, 6, 7. 7. So here is 2, 0, 1, 102. So still you have not got here. So something you have to carry out the further step here. Therefore, 867 is equal to 255 into 3 plus 102. Again, apply now. Again using Euclid division lemma. What you can write here? Now this number will be acting as a dividend here. 255 divided by 102. 102 ja. 2 2 ja 4, 2 0 0, 2 1 ja 2. That means 51. Yet you have not got 0. You have to carry out further steps to get 0. So you therefore, what are you going to 255 is equal to 102 into 2 plus 51. Still you have not got 0. So again, right? Again applying what? Applying Euclid division lemma. So here what will be the dividend? 102. 102 divided by 51. 51 2 ja 102. The remainder is 0. Rahat. That means we finally got the remainder 0. The answer stop here. So what you can see, for what it may become 0? For 51. That means we can write the HCF of 867 and 255. Therefore, here what you can say, 102 is equal to 51 into 2 plus 0. Therefore, the HCF of 867 and 255 is what? Is your 51. I hope it's pretty clear, everyone. So pause the video to note it down, and the video will be quite lengthy. So rest up question 2, 3, 4, 5 I'll be uploading in the next awaited video. Thank you, and please provide your valuable support. Thank you.